students, Ms. Mason here, and we are here for Geology lesson number 10. 10. Brutus 10? High five? Oh, I might lose a finger if I try to do a high five with Brutus. I do want to introduce my co-host Brutus, and having the parrot involves a lot of commitment. I did not buy him. I adopted him from an avian vet, so a vet that specialized in birds. His previous owner did not want him. I don't know what happened, but he was kept at a boarding part of the veterinary clinic, and I worked at the vet clinic, and that's where I met Brutus. And he used to say, well, he still does, he just want to scratch my neck, and he would take his foot and scratch his neck. So he was doing it at the clinic. He'd always say goodbye when I'd leave the room. He was well known for shredding everything though. So if you put paper on the bottom of his cage, it'd be shredded. But anyway, I just want to make sure that the presence of Brutus does not get you interested in maybe wanting to purchase a parrot. Please do not. Unless you adopt only, and even if you adopt, it's almost a lifetime commitment. They can live till over 60 years old. Brutus is 24. I believe this. I've had him for 20 years, actually. I've had this bird 20 years. Adopted him 20 years ago. There are so many unwanted, neglected parrots, pet parrots, from people that have bought them because they want them to talk. They like the novelty of talking. Yes, it's exciting and it's fun to have a parrot, but it is a huge commitment. It's like a marriage. It's like having a child. So please think twice about adopting and never buy. I would never buy a parrot, ever. I would not support the pet trade, because even though a lot of the most reputable pet stores have parrots that have been raised in captivity, raised in the U.S., but there are still some that are not regulated, and they import them directly, and these from Africa, Congo rainforest. So they're actually endangered in the wild, which is very disturbing, and it is really because of, one of the reasons is the pet trade. It's also habitat loss. But I would not have him unless he were available for adoption. I just adopted him from the clinic, so I would never buy a parrot. So I just want to make sure everybody understands that, because I don't want to seem like a hypocrite where if you think I'm supporting owning wildlife or wild animals. They do not belong in captivity. The only thing is I can't release him. If I release him here, he has been raised in captivity. He wouldn't survive here. And re-releasing him back into his native habitat is almost impossible. Here he wouldn't make it. So he has been adopted, but think of like the Tiger King show is very disturbing to me. I couldn't watch an episode. I don't know why it's like they're using these animals to make money, and these animals do not belong in captivity. And there's some places that rescue them legitimately from circuses, like tigers and elephants. There are some rescue operations. But the dead indication they're not in it for just rescue is if they're breeding them. So if they're carrying around baby tigers and doing photo ops or want a selfie with my baby tiger? No, because they are breeding them, and a lot of them are inbred now. They're even breeding different species like lions and tigers, creating ligers. So it is a huge problem. It's just using the animal as a prop. For money. So it's just, I don't support it, and I know some of you might be watching the show, but I couldn't watch an episode of that. And actually I went to vet school for 3 years, veterinary school. I wanted to be a horse vet. And after I got into it, I realized that I liked the interaction with students. I like teaching more and the creativity of teaching. But the vet school, I went to University of Florida's College of Veterinary Medicine for 3 years. And it is close to that place where the Tiger King is filmed. And I actually had heard of it, and some of my my colleagues, my classmates in vet school actually went to that rescue. We're talking about it, and they were actually posting pictures. And but it really bothered me because I could just tell that that place was not meant with the animals' welfare in mind. It was more of a like a roadside zoo, not accredited, and just really taking advantage of the novelty of having tigers to make money. So please, that's I don't want to lecture him that too much, but I just want to make sure everybody understands my perspective that he was adopted. I do not support any ownership of exotic animals. Okay, now today we are talking about going back to geology. So geology, study of the earth, the hard parts of the earth, the rocks. Okay, today we are going to talk about, it's called seismology. I'm losing my marker. Got an order on Amazon, another one. Another order on Amazon. Might be a few months though before I get it. Anyway, so seismology is, remember, anything that ends in ology, words, ology, means the study of. So I'm going to have to come around here. Now Brutus is, you have to move slower on Brutus, otherwise he's a fight or flight, and he flies. So it's, well, sometimes he fights. But. All right, the study of, ology. Seismograph, think of seismographs. This is the study of earthquakes. So, seismograph. So this word, seismology, study of earthquakes. Actually, here's earthquakes. Earthquakes, right? And they're waves, they're seismic waves, so that's why it's seismology. We're talking about a seismologist. Words in IST, that is one who does something. So a seismologist studies seismology. Seismic would be an adjective describing a wave. So coming from this though. Okay, so now we're going to look at when earthquakes happen. Obviously we know now how they happen. So we have, just to review, two plates. Okay, we're going to have, this is going to be the Pacific plate. LA, let's say, is on this. Los Angeles. San Francisco's on this one. This is the North American plate. Okay, they are next to each other in a transform boundary. So they interlock. So if I zoomed in on that fault, the San Andreas fault, it would look kind of like this. Jagged edges, they're interlocked. All right. So remember, San Andreas fault is really a fracture in the earth, and it's fractured because that's where these two plates are interacting. Okay, so we have North American plate, San Francisco, Pacific plate, LA. So LA's plate, Pacific plate is moving north, and North American's moving south. So this is happening. All right, so most of the time there might be small earthquakes, so it might get trapped a little, but it still goes. So we wouldn't feel it. It happens every day. In fact, if we look at the record today, we might have already had a couple. We didn't feel it. So this is common, that they just slide, but sometimes they get slightly trapped and they keep moving. Sometimes though, they really get trapped. They just can't, they get stuck. So if they're stuck in this position, there's a lot of pressure build up because there's forces involved. So there's forces that move these plates. The forces are those convection currents. That's where it starts from. Right, so remember, a force is a push or a pull. So if I push something or I pull, that's a force. So force, push, or pull. All right, push, pull, that's a force. So there's, this one is wanting to move. All right, it's like pushed by those convection currents. And this one's being pulled by convection currents, whatever you want to call it. All right, so when they can't move, there's a lot of pressure, there's a lot of energy in there, it's trapped, it needs to escape. It's got to escape, and it's released in the form of the shakes. All right, so those waves, is spread from the middle of the earthquake, the center of the earthquake, the focus of the earthquake. Remember the hypofocus, so that's where the earthquake starts. So waves, so that's energy being released. It's like being stuck in traffic on 280 for 2 hours. There's a lot of pressure buildup. People are upset, they're honking their horns. It's like a parking lot, nobody's moving. People's tempers are flaring, starting to exhibit road rage or cussing at each other. People are running out of gas. All right, and then all of a sudden, let's say it's an accident or something. All of a sudden, they pass the accident, it clears out, and everybody goes about 100 miles an hour. All right, so all that pent-up energy, all that contained, pressurized energy is going to be released. And think of those cars leaving now, that's like area where there's a lot of traffic. They're spreading out like waves. All right, energy travels in waves. Waves are how energy moves. How does energy get from one place to another? So if I hear thunder, or there's a lightning, a thunderstorm, and this window over here starts to vibrate after the loud thunder banging. All right, that's due to those waves, those sound waves coming from the thunder. All right, they actually push and pull that window. And those are called P waves. So it relates to this because earthquakes have the same type of waves, same category of waves. So the main type, there are 3 types of earthquake waves. So I'm not talking about waves now, I'm talking about the earthquake waves. All right, 3 types. The first type is called the P wave. Woo, he's knocking now. He's getting comfortable with the camera now. P wave. All right, this is the primary, stands for primary, P primary wave. And if you think of, let's stick with P because it might help you remember. Primary. It's a push. That word. It's a wave that pushes and pulls. All right, push and pull. So
longitudinal waves using a slinky. So longitudinal waves, these are the P waves. They move pretty fast, and they involve compression, pushing, and pulling.
When you hear thunder, it causes the window to shake, because the thunder is traveling in sound waves. And when the sound waves travel through the glass, they actually bend or refract, but they also, when they push and pull the window. So, waves are all around us, everywhere. If matter is anything, has mass and takes up space. So you matter, Brutus matters, I matter, we all matter, because we have mass and we take up space. So if we're talking about this slinky then, if the wave goes the same direction as the slinky, that's called a P wave or a longitudinal wave. So lengthwise, think longitudinal, lengthwise, straight now. The second type of seismic wave is called the S wave. Now, if you think of S, we're going to use some alliteration, which is when you use the same letter at the beginning of the words over and over and over. So S waves are slower than P waves, and they move sideways. So we're going to say a slow, or a slithering snake, Okay. Slowly slithered on a solid sidewalk. So it's also called alliteration in English. when you use the same letter at the beginning of the word, so this is all S's. So think of S wave, it's a secondary wave. So secondary, that's where the S comes from.
Okay.
Primary was the P wave. So secondary waves are slower and they move sideways. So in this GIF, I'm going to show you this video of a Slinky. So in this case, the direction the wave moves, direction of wave is perpendicular, meaning it forms a 90-degree angle. Perpendicular.
Okay.
So this is an example of S waves or transverse waves. And remember, transverse waves these are the secondary waves in an earthquake. So these are slower. So if you look at this Slinky here, the direction that the Slinky is moving, you can see it's going up and down. So the Slinky is going up and down, but the wave itself is moving from left to right.
The wave is going that direction. So wave goes that way, Slinky's going this way. So that's a 90-degree angle. Okay, so it's perpendicular. Secondary waves can only travel in solids. So this is why I said solid sidewalk. Or they cannot go in the outer core because the outer core is made of liquid metals. So it's liquid iron, and the S wave cannot travel through that. So that is the second type of wave, is the S wave. The third type of earthquake seismic wave, they are called the surface waves. These are waves that you feel on the surface of the earth. All right, and I showed you a video of the turkey taking a drink, creating those surface waves in the water. So there's also surface waves that would travel outward on the very surface of the earth. So those are surface waves. So P wave is the fastest. It's a compression wave. Think of push and pull, P wave. That means the wave moves in the same direction the matter moves. All right, S waves, the direction that the wave is traveling is perpendicular to the direction that the matter is moving. So if you think of Slinky, it's going sideways. So a way to remember that is a snake is slowly slithering on a solid sidewalk. S waves only travel through solids, not liquids. And then the third type are the surface waves on the surface of the earth. So these are the three types. You should know about these because we're going to use them to figure out the epicenter or the locations of earthquakes and the time earthquakes actually occurred. So geology rocks.